Now, a nerve impulse. Well, the way that a nerve impulse functions is that normally you're going to maintain high concentrations of sodium outside of the cell and potassium inside of the cell. Stimulation of a neuron opens a sodium channel, allowing sodium to enter, resulting in depolarization of that cell. Okay, depolarization induces a voltage-gated potassium channel to open, and before the concentrations of sodium and potassium can equilibrate, the channels close, which propagate that signal. Okay, so in addition to that, we have this display of what happens. So here's a crude or a simplistic representation of what happens for a nerve impulse. What we have is a calcium channel, and then we have all of these synaptic vesicles that have acetylcholine in them. Now, here is our muscle cell, and this muscle cell has these acetylcholine receptors. So there's going to be an action potential that reaches an axon terminus. This causes this voltage-gated calcium channel to open up. So this channel is going to open up, enabling the intracellular calcium ion concentration to move in here. So we've got all these calcium ions that are going to be flowing into in here. So Ca2+. Okay, what that is going to do is cause these these synaptic vesicles to merge with the plasma membrane down here, and those vesicles, as they merge, they're going to release this acetylcholine. That acetylcholine is going to then bind to these receptors on our muscle cell, and this is going to lead to muscle contraction. This signal is very brief because acetylcholine remaining in the synaptic cleft is rapidly broken down. But if you have those acetylcholine esterase inhibitors, well then this guy is going to stay there and continue allowing that to take place. So in a similar way, you have a stimulus over here. So this is just you have a neuronal cell and a stimulus that causes a sodium channel, or causes sodium ions to flow into the cell. So we've got a plus 50 millivoltage is our electrical potential here. Now what that is going to do is that's going to cause a potassium channel to open up, enabling potassium ions to flow out of here. Well, that's going to cause a depolarization, which enables the sodium ion to flow in while these potassium ions are flowing out. And what we have here is a movement along this neuronal body. So that we have ultimately the stimulus over here that is propagated down to the other end of our neuronal cell. Well, I hope this is helpful, and I'll see you in the next video, which I believe it's our last. Alright, well, thank you very much. Have a good one.